I've been doing lately.
Did you just collect this, Martha?
I did.
I told him
Pass it back out, and I'm
I
gonna
told
go
him not to. I
go.
go, you better not do that.
I just realized. I know. Anyway, so
Why do you hate
what we
me?
left off with last week, it seemed like a week ago. Anyway, on Tuesday, I kind of gave you guys the hint that eventually you're not gonna know where to start when you're trying to find zeros. So that's where we come up with the ideas of what's called the rational zero theorem, rational root theorem, sometimes people call it. And you'll have to excuse me, I saved the wrong file, so I screwed up this morning and I just now noticed that. So I'll be doing a lot of erasing. What happens is you get this rational zero theorem. Bless you. And remember from last week, in order to list the possible zeros, what you do is you take plus minus all the factors of the constant divided by the factors of the leading coefficient. And it goes into this whole rigmarole of if f of x is a sub n x to the n plus dot 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 a sub 1 x plus a naught, whatever. Put a function in descending order, look at the constant, what are the factors of the constant, divided by all the factors of the leading term's coefficient. So in this case, my constant for the function was x cubed plus 2x squared minus 11x minus 12. My constant is 12. The factors of 12 are
1, 2, 3, 4, 6, and 12. That's not how
good.
I learned to count.
Okay. And then the leading term coefficient is 1. So that tells me I'm going to have 6 possible zeros for this function. Yes, sir. Thank you. I meant this. I didn't multiply my. Yes, there's 12 because you got plus or minus 1, plus or minus 2, and so on and so on. Okay. Yeah. From all the factors of the constant divided by all the factors of the leading term coefficient. The one that doesn't have a variable. 12. Okay. So what this is going to allow you to do then is know where to start factoring. For example, in this problem here, we have, I like to start at 1, bless you, and work my way out. And then I'm just going to synthetically divide. If I get a 0 at the end, great. If I don't, I erase and I go again. And obviously it's not going to work. I went up to -8. I know it's going to get me there. So I erase and I go again. Now, third hour, I was really nice to them for some odd reason. I'm not quite sure why. But I had like a bunch of erasers. I only have 4. Well, they're all kind of normal. I have 2 tigers, an elephant, and a hippo.
Oh,
Hey,
I honestly need one.
go penguin. Tiger. You did show me a cool thing. Yeah, it's true.
You made
I have a bending
All right, so what? Ooh, fancy. All right, it's quick. All right, anyway. I'm getting more, and we'll get more. Okay.
Oh, fancy.
Or you can just take it back and there.
If you're nice, I'll show you guys another cool thing. Hey, I found a 0.
Wow.
So, what I want you guys, what we're going to start doing is we're going to start factoring these things fully. We're going to find all possible zeros as we go through. Now, once I get a 0, that meant that -1 was a 0, which meant that there was a term, x plus 1. I want us to continue using synthetic. So at this point, I'm going to draw another synthetic bar below that. But yet, I'm going to stop before I get to that 0. I'm going to put a little x through that so I don't accidentally try to go back and add to it. All right? Because what I've done is I've dropped it a degree. We have factored out an x plus 1, so right now I'm left with an x squared, a 1x minus 12. I could try and factor that, or I can use synthetic. What I want you guys to get in the habit of doing is check for your multiplicity. What was multiplicity again? The thing of repeated zeros?
Yes.
So, if -1 was a 0, I'm going to try it again real quick to see if it was repeated at -1. So I just do that, 1, -1, 0, and it's not going to work, so I just go on. Hallard was in here last hour, he was doing his homework for third. And he had a question, he's like, do I start over at +1 when I drop to the next degree? And I said, no. Because what happened is that once you factored out that +1 and you checked it again, you just continue on. Because if 1 didn't work originally, it's not going to work now. Think about it this way. If 3 doesn't go into 14, would 3 go into 7? No. Same idea. You don't double check the ones that you know already don't work. Okay? When you start going through factors, you don't double check. So we've already gone through 1, we did -1, I just checked 2. Yes, you can factor, but I'm just saying eventually.
Okay, I was just answering.
Yeah, chillax. Or you want to be cool, what times what? And yes. I would have gotten there eventually.
No, I just was asking.
You always ruin the fun, Sam.
Wait, so do we factor?
Absolutely. Yeah, absolutely. I was just, sometimes yes. I would have gotten it eventually as -4 or +3. All right, same idea. Throw it. Oh, we just did this one. I just realized that. Sorry. I know. It's supposed to have worked earlier. Apparently, I just forgot to. That's what happens when you don't save the right file. They go back and fix it. Oh well. So let's do the same idea with this. We're gonna find all the zeros, all the zeros for this one. We've got function is 2x to the 4th minus 9x cubed plus 8x squared plus 9x minus 10. So we start again listing out all the factors of the constant divided by all the factors of the leading term's coefficient. So I have plus minus 1, 2, 5, and 10 divided by 1 and 2. This means I could get fraction ones. What I want you to notice here is that you get 1, 2, 5, 10, 1 over 1, oh, excuse me, 1 over 2, 2 over 2, 5 over 2, and 10 over 2.
And on the negative.
Yeah, plus minus, excuse me. But some of the fractional ones are repeated. See how the fractional of 2 over 2 is the same thing as 1, 10 over 2 is the same thing as 5? You'll notice that sometimes you won't have to check them. More often than not, the fractional ones are the last ones you get, like the example we had where it's 2x minus 5, where we had 5 over 2 is the 0, or whatever, plus 5, I think. That fractional one is usually the last one as you're synthetically dividing, because I kind of know how you guys are. You're going to check all the ones that are integers before you go to the fractions. You're not going to start at 5 halves and work your way backwards. Yep.
You right.
I know. So we start with our synthetic. Start with 1, 2, negative 9, 8, 9, and negative 10. Hopefully by now synthetic has gotten real quick. Hey. So I got a 0 at 1. So I know that I have a term, move this over a bit, at x minus 1. Always double check multiplicity. Yes, Marcy?
So why is it 1 and then it's x minus 1?
1 is the 0. The term that creates 1 as the 0. So always double check to see if you have multiplicity.
What?
No multiplicity. Okay. So I'll try negative 1. Oops, I'm starting to multiply. Yay! Negative 1 is a 0. Therefore, its term would be x plus 1. You're now at a quadratic. 2x squared minus 9x plus 10. Might be factorable. Two times 10? Add together to get negative 9? Negative 4, negative 5. Those are your other two terms. When you factor out the grouping. So you have total zeros now at, or terms, 4 of them. Zeros at 1, negative 1, 5 halves, and 2. So even if you didn't want to group it or and factor at that point, the next number on your list to check would have been 2. And you would have gotten a 0 by synthetically dividing out by 2. And you would have been left with 2x minus 5 for your term. And you can get that 0 real fast. Okay. So it's totally up to you if you want to factor it how it's sitting, or keep, bless you, or just keep going through synthetic division. There's no rhyme or reason as to which one's better. Yes, you can.
So if it doesn't work out, do we have to like keep that, or can we just erase it and start over? Like, we don't have to show you every single one we attempted, do we?
No, but that's why I was giving you guys some erasers, and I need to get more.
Did you say we're eventually going to do imaginary solutions? for
Yes.
this? What? How would that work?
We're actually gonna still be able to. We're gonna synthetically divide with imaginary numbers as well.
Yeah, that's impossible.
Nothing's impossible. Nothing's impossible. You said it's impossible. It's not impossible.
Just do it.
Wait, no! Who's maybe thinking about going
Don't let your dreams be dreams.
Yesterday you said tomorrow.
So just
Oh my
do it.
God.
All right.
Alright, thank you, Mr. Murphy.
All right. So we just did that.
You're gonna get the point to the point where everybody else will give up. Not you.
You still have any questions?
Yes, ma'am. Yeah.
We had the x plus 1, x plus 1, it'd be all four of those quantities, right? Mine's still in there.
All right. Let's factor this one all the way out. Do the same thing. 2x cubed minus 5x squared minus 14x plus 8. So we start this one out by listing all the factors of the tail, divided by all the factors of the leading term.
So many negatives.
And if you look at it, in terms of the fraction, there's only one fraction you have to worry about. The plus minus would be the 1/2. 2 over 2 is 1, 4 over 2 is 2, 8 over 2 is 4. So you already have those accounted for. And that happens quite often. Okay, that happens quite often. So you start at the front, work your way through. Bless you. Bless you.
So close.
But yet so far.
You're going too fast, Carmen.
No, keep going that fast, because somebody might not be right. We'll get it this time.
Yay! Took us 3 tries. 3 times so bad. Third time's a charm. Wait. What? Synthetic? No synthetic division not fast.
Because you have to go through trial and error.
I have 2 words for you. Wham. So we have a 0 at -2. Check it again.
Nope.
Nope. Go to 3. It's not 3, 4. Forgot where I was. 4. Hey! So I have x minus 4, and look what's left. 2x minus 1. What's up?
It's great.
And yes, there is an easy way to start these problems. You can put them in your graphic calculator and find a 0, but are you going to get that?
Why did you do that?
So you have zeros at -2, 4, and 1/2. What are the tails doing?
Dancing.
Wait, stop.
Stop.
Down, up, right? Should be down, up. What's up?
My brain isn't working.
He's about to
The last 0.
Hmm?
How did you get the last 0?
For this part here? Remember, this started as a 3rd degree.
Yeah.
This went to a squared. And this is a 1st degree. 2x cubed, 2x squared, 2x.
Oh.
Bless you.
Bless you. I gotta remember that.
All right, well, let's do this up with the imaginary then. No. No, I don't hate you.
It's not.
It's not.
He's just glad.
Oh, I'm sorry that my opinion is wrong.
It's obnoxious.
It's obnoxious.
Basically, what 6, 7 entails, we're only going to talk a little bit about 6, 7, and 8. There's quite a bit more information in it, and we're going to leave more of it for tomorrow and Monday. What happens now with what we call the fundamental theorem of algebra basically states, and you guys have heard me say this, the degree of the polynomial is going to tell you the total possible number of zeros. It doesn't necessarily mean you're going to have that many real zeros, but it still says that you can have that many zeros of a function. So if it's a 5th degree polynomial, you can have up to 5 total zeros. Real and regular, or imaginary, see what that word was called. I was thinking about it, I just forgot. Get a quarter.
I don't have one,
Do you have a quarter?
Somebody give them a quarter. I have a quarter.
Can I have a quarter real quick?
Yeah.
I showed this the other class, I'm going to show you this too. I don't remember why I did.
You're just gonna take a quarter.
If you want.
Oh, I don't need it. JC, catch.
Wait, how'd you do that?
Do that again.
Snap it.
Watch out, guys.
You're gonna hit yourself. The way you're holding it, you're gonna hit yourself.
How am
No.
I supposed to hold it? Like that? Oh, like that?
Alright, so like I said, the degree of the polynomial always tells you the total number of possible zeros, real and imaginary. This case here, I've got x to the 5th minus 2x to the 4th plus 8x squared minus 13x plus 6. Fifth degree polynomial, how many total zeros can I have? How many changes of direction could I have? 4.
Who said that?
Remember, change directions is n minus 1 degree. My tail here is 6, so my possible zero is going to be plus minus 1, 2, 3, and 6 all over 1. Fairly easy. Now, I have a fifth degree polynomial, which means how many terms should it have?
6.
Which is it?
6.
All right, so there should be 6 terms there. There's only 5, which means I got to put a placeholder in. Where do I put the placeholder? At the cubed. Okay. You still have to make sure you have placeholders, otherwise bad things happen.
You go so fast. You're driving me insane.
I found a 0.
Woo!
I'll go slower. So I have a 0 at 1, which means my term is. What's not
Negative
right?
1.
So I have a 0 at 1, so it's x minus 1. Make sure you guys keep a tally on your zeros. One of the ways by just relisting it or circle it, knowing that it's a 0, you're putting a 0 around it. Okay? Always check for multiplicity.
Okay, Mr. I get it.
I found another 0.
I'm so. Oh my
At 1.
god.
Remember, what I'm doing here, what I'm doing here is I'm always checking the multiplicity at the value that I just chose. It takes a second to check it. If it works, great. If it doesn't, you go on.
Wait, so what does that mean now?
It just means that there's a multiple 0 at 1. So it's got multiplicity. It means the graph is going to touch it at 1, change direction at 1. Somehow. That's all it means. Okay. So now I have another 0 at 1. So the next one for me to check.
Wait. So you only check it
You have to check
twice?
You can. You can. It doesn't hurt. And you'll find out real quick it doesn't work.
Does it never
Yeah.
work?
Okay, it can work. It's very rare, but it does work. It just means you had a cubic there. That's all. So if you do check 1 again, for fun.
Don't make fun of that.
And you see right away it doesn't work.
I used to do math homework for fun.
No, that's okay. There's nothing wrong with that. So then I go to -1 and I check it at -1.
We're dropping real bombs here.
And it doesn't work again. So now I go to 2. Oh, so close.
You don't even give me time to erase.
Because Mr. Murphy can erase faster than anybody. He's really.
Oh, that's.
Yeah, whatever. So what happens now, and 2 didn't work, but -2 did, so I have a 0 then at -2. So I have a term at x plus 2. So now I'm left with,
You're going to check for multiplicity again, right?
well, before you do that, right now you're at a quadratic.
Oh, yeah, right.
X squared minus 2x plus 3. When you get to the quadratic, always check and see if it's factorable. A lot of times it's quicker, especially if the leading term coefficient's at 1. So what times what's positive 3 add together get negative 2? Nothing. Quadratic formula then. Now that we're finding all zeros, you got to go to the quadratic formula. Quadratic formula was x equals negative b plus or minus square root b squared minus 4ac all over 2a. Notice I over-exaggerated the all over 2a. Bless you. Anyway, a lot of you guys in the past have accidentally just put the over 2a part underneath the radical. The entire numerator is divided by 2a, okay? The whole thing. That's why it's all over 2a. So you go through it. You get the opposite of b is 2. Plus or minus the square root, we get 4 minus 4 times 1 times 3, all over 2 times 1. 4 minus 12 is? Negative 8. Which means I'm going to have an imaginary solution. What's the square root of negative 8?
2i root
2i root 2. Okay. So this becomes 2 plus or minus 2i root 2 all over 2.
That's a lot of 2's.
What I want you guys to remember is that all over 2 is kind of like having a common denominator when you're adding and subtracting. It's the exact same thing as saying 2 over 2 plus or minus 2i root 2 over 2. So that means you can simplify. Your final answer becomes 1 plus or minus I root 2. And that's my other zeros. Our other zeros were way, way, way up here. Came from those. So your final list was 1, 1, negative 2, and 1 plus or minus I root 2. Yes, sir?
Can you go back a step? I don't know where you got the 2i root 2.
Square root of negative 8. Square root of 8 is 2 root 2. Square root of negative 8 then into I root 2. And I get 5 total zeros. 1, 1, negative 2, 1 plus I root 2, and 1 minus I root 2.
So how you know it's a quadratic if there's 3 numbers?
What do you mean?
Like, after you do
Oh, yeah. Because remember, every time you're synthetically dividing, you're dropping a degree. So we factored out a plus 1, then the x plus 1, factor out another, or sorry, minus 1, factor out another minus 1. So we started at 5th degree, factor one out, we had 4th degree, factor another one out, 3rd degree, factor another one out. Yes, sir.
I did.
How would you put the
Really hurt.
the 1 plus or minus I root 2 into the terms like x minus 1?
I'm going to show you guys that later. Okay. I will show you guys how to build those terms. We will build the functions with that, and we will use I for synthetic division.
Homework?
Why would you ask for homework?
It's going to happen anyway, so she can. Okay.
She's just expediting.
Because
What I
I'm
have for you guys. A lot of times it's the easiest thing to go down, to keep going until you get to the squared one, then use quadratic. 6, 6 was just finding the real zeros. 6, 7 is finding all of them. That's really the only difference. So in most of the instructions, you're doing the exact same thing. But if it says find the real, you just find all your reals. If it's finding imagine, finding all, you're finding them all. Okay. You'll be working on this tomorrow as well. I'm going to be stuck in a meeting all day, selecting materials for the new Algebra 2 book. I'd love it. Great. But it's basically I just basically have you guys doing the same stuff. On Monday, I will show you guys the more difficult way of writing out the terms when you're given an imaginary solution. How do you write that as a function, working backwards. And then we'll get into graphing and all that. Yes, ma'am.
Can I tell you a story?
What do you got?
Okay, so this past weekend, me and my friend went to
My friend and I.